Section 4.1. Today we start Chapter 4. Chapter 4 deals with exponents and logarithms. Okay, exponential and logarithmic functions is Chapter 4. Section 4.1 is basically just reminding us of the basics of exponential functions. Okay, so we're going to evaluate exponential functions. We're going to graph exponential functions, which is going to be the funnest part of this whole lesson. We're going to evaluate functions with base e, and we're going to use compound interest formulas. Okay? Evaluating exponential functions. Let me make sure you have some basic understanding before we start. If I say f of x equals 2x plus 5, can you tell me what f of 3 is? Well, what used to be right here? An x, right? That means anywhere there's an x, we want to put in a 3. 2 times 3 is 6, plus 5 is 11. Done. So, can you do an exponential function? That was obviously a linear function, right? Can you do 2 to the x power plus 5 and find f of 3? Well, what's 2 to the third power? 8 plus 5? Done. How comfortable do you feel evaluating exponential functions? Yeah, they get so much harder. F of x equals 3.5 times 2.3 to the x power. Let's say f of 4 this time. Yeah, that's when we have our friendly neighborhood calculator to help us out. Because I don't know what 2.3 to the fourth power is. I don't have to. Okay? I need a new document. That's a calculator. And I literally put in 3.5 times 2.3 raised to the fourth power. Guess what the answer is? Exactly what it says on the screen. 97.9444. Done. You got evaluating exponential functions? Any questions on it? Okay. Graphing exponential functions. So if I say f of x equals 2 to the x power, you actually should be able to graph this without a calculator, for the record. Because that's the parent function of a base of 2, right? So without getting real specific, I do know that it goes through this point right here. How do I know that? When x is 0, what's anything to the 0 power? 1, right? So I know the point 0, 1, I know it's going to pass through that point. Because the base is greater than or equal to 1, we know that this is exponential growth. And what's exponential growth look like? Done. Is it ever going to go down and cross this x-axis? What exponent or what x value could you put in here to make this negative? Nothing, right? The only thing that can make it go over the x-axis on the other side is if I use my transformation rules and put a negative in the front. That would flip the whole thing over the x-axis. Okay? Well, what would happen if this actually said f of x equals 1/2 to the x power? What's the base here? We'll call the base b. Okay, so in this case the base was greater than or equal to 1. This time the base is between 0 and 1. So this is called decay. Remember that? Now, I need you to realize that the textbook and maybe your homework calls this increasing and this decreasing. But that's also not something I worried about whether you could figure it out. Okay? Does this one still go through this point 0, 1? Because anything to the 0 power is 1. It just goes like this. Oh, great. I didn't even make it go through the point. Use your imagination or I'll just make the point a lot bigger. How about that? Okay? Any questions about graphing? If it gets any more complicated than that, which it will, and you know that, okay? Like this. Can you tell me everything that's going on here in this equation? Compared to the parent function, we're going to call the parent function 1/2 to the x power, right? Because that's the base that's there. Compared to its parent function, what's happening? What does that say? Reflection over the x-axis. What's that say? Vertical stretch by a factor of 4. What does the 1/2 say? Nothing. That's the shape, right? That's its basic shape. What's that say? Horizontal shift, left 3. And what does that say? Vertical shift, down 2. Oh, down 2. Because that looks a whole heck of a lot more difficult than this, but it's not because we just did it. Okay? Any questions about that? If it asks any more specific kinds of details, really what it's going to want to know is, could we graph this? Well, we can kind of sketch it, right? If they want a specific graph, we're definitely going to just grab our calculator. Okay? We know this is decay. Whoa, sorry about all those dots. We know it's decay because the base is between 0 and 1. Okay? What point do you think we shift around on a parent function like this? It's that one. That's the point we shift around. Okay? So it's normally right there. We need it to go left 3, and we need it to go down 2. Okay? So I know it's going to go like that somehow, but there's also vertical stretch by a factor of 4, so we've stretched it this way. So instead of something like this, it's going to be more steep, like that. Got it? Again, if they want anything more specific, we have our calculator. Okay? Now, there is a point, or a line, I guess I should say, right here. That's an asymptote that it's never going to cross, is it? I apologize for making it look like it's going back up. You know that it's not. It's getting closer and closer to that line, but that's really hard to draw. Okay? How do I know that it's 1 below this dot? Where's this asymptote? 1 below. Okay, so it's 1 below. Got it? Any questions? Okay. Next, evaluate functions with base e. Do you guys remember talking about base e? Okay. So here's what I want to remind you about base e. That's approximately equal to e. 2.718281827. It's an irrational number, which means what? It goes on forever, and since it's irrational, we cannot write it as a fraction. Okay? It's called the natural base. Well, we have the common base, which is 10, and then we have the natural base, which is e. Okay? Why is it called the natural base? Do you know that? We talked about it a little tiny bit in Algebra 2, but we didn't really focus on it because it wasn't really a focus. It's a good guess. It does. Absolutely, it occurs in nature. Okay? Pine cones, flowers. Have you ever heard of the golden rectangle? Okay? No? I have a video I want to show you then. It's called Donald Duck in Mathmagic Land. Oh yeah, you got to search it up on the internet. It's pretty cool. Okay. It talks about golden rectangles and stuff naturally occurring in nature, which seems a little overuse of the word natural or whatever. You know what I'm saying. Okay. This number does occur in nature a lot. Okay. It also is nice to have when we're talking about interest formulas, which we will talk about in just a minute. But basically, what we have to make sure to be able to do for our objectives today is evaluate functions with base e. So just like we did before, f of x, we said 2x plus 5. We could figure that out, right? Now we're saying 4e to the 5x. Can you evaluate that function if I say f is 2? 4e to the 5 times 2, so 4e to the 10th. Can you turn your calculator on and say 4e raised to the 10th and hit enter? If you can do that, you're going to have no problems with this part. Okay? Evaluating with base e. A lot of people don't like it because we've just always talked about letters being variables, and this e is not a variable. It is a set number. Okay? It's approximately this, but we can't write it as a fraction, and it continues on. Okay? That's what it means by irrational, but you guys know that. Okay? So as long as you can evaluate stuff with e, we're good for that. Okay? And then the last thing that we have to do for this objective is we have to use the compound interest formulas. Okay? There's two that we're going to focus on. And I will make sure that you have these. These are not something I'm going to make you memorize. Okay? The two that we're going to talk about are this one and this one. Now, A and P and T in both formulas mean the same thing. Okay? A is the amount. Oh, what am I spelling? I don't know. Okay, that was my brother-in-law. Amount of money or amount that you end with. And P is the principal. Not like Mr. Wilson, the principal, but the principal, like amount of money. It's the money that you start with. Okay? T in both formulas means the same thing, and it means the time. And typically, it's in years. I also forgot about R. R is the same in both formulas, and it's the rate. And it's given to you in a percent, so you have to make sure to fix that before you put it in the formula. Okay? If it tells you 6%, you can't just put in a 6 right there. You have to convert that to a decimal, which would be 0.06, right? Okay? So the only thing that's different really is the n here. And we'll go ahead and define that just so we have that. It's the number of times the interest is compounded. I said R was rate. It's the interest rate. Okay, so it's the number of times this interest is compounded. So for example, if I tell you yearly, then what's n? How many times a year is yearly? 1. What if it's monthly? N would be 12. What if it's weekly? Try again. 52. How many weeks in a year? Okay. Any questions about that? And for the record, there are actually 7 days in a week, not 6. Just so we're okay. I'm pretty sure. Yeah. So we have to make sure to remember our decimal thing for that one, this one for this one. Okay? Now, we use this formula a lot in Algebra 1. Okay? We use this a little because it was part of our lessons, but this is when it's compounded a certain number of times a year. That's why we've got the n in there. How often is this compounded? Continuously. Okay, that's when the interest is compounded continuously, and then this is when there's a number of times that it's compounded. Okay? What do I put in for E here? I didn't define it. It's just a number, right? I don't have to define it. It's the number that we talked about right up here that I'm pointing to that you can't see. Okay? Do we need to do examples of that, or you guys got that? Remember that from Algebra 2. It's pretty straightforward. It's just the same stuff we did in Algebra 2. Just doing it again now. Okay? Yes, it is. It's word problems. Okay? Because if all they do is give you, if they tell you A and P and R and N and T, that doesn't make any sense. Like, they want to be able to make sure you can get stuff out of a word problem and put it in. It'll be something like, find the accumulated value of an interest or of an investment of $10,000 for 5 years at an interest rate of 5.5 if the money is compounded quarterly. Ooh, we didn't talk about quarterly. What's quarterly? 4, yes. You got it? Does that make sense? Do you have any questions about this?